Hey everyone, it's that math magician, and on this video we're going to learn our final similarity condition that we refer to as SSS similarity or side-side-side. So what we got going on here is we have these two triangles below where we know all three sides on both triangles. Hopefully you can see that we don't know any of the angles inside these triangles. That means angle would not work because we don't know any of the angles inside. And side would definitely not work because we need to know one of the angles in the middle of the two sides, and we don't know that at all. So that is why we instead want to use this third similarity condition that we call side-side-side, where we want to look and see, does every side have the same zoom factor to the other triangle? If they do, then the triangles are similar. So let's dive in and see whether or not these two triangles, with all of their sides, if their corresponding sides have that zoom factor. So we have down here triangle CAT, and then we also have triangle DOG, and hopefully we can see that DOG is the same as this triangle CAT on the bottom, but it looks like it's been shrunk, and then it looks like it also has been rotated a little bit. So I did it this way so we can see that this side here CA is going to correspond with this side DO, right? Those two sides are the same. If I were to take this triangle and rotate it back, we would see that both of those sides correspond. So let's go ahead and start our flowchart and talk about these sides, and let's determine what the zoom factor is. So I'm going to take side CA, I'm going to put it over side DO. Well, CA has a side length of 16, side DO has a side length of 4, and 16 over 4 becomes 4. So right now, those two sides have a zoom factor of 4. Our goal is, do all the rest of the sides also share that zoom factor of 4? So let's go ahead now and focus up on the base of the triangles. That would be side CT and side DG. So let's again compare those zoom factors and see whether or not they have this zoom factor of 4. Now we want to be careful. Some mistakes that students make is, if you notice with this first ratio, I did the big side over the little side. Sometimes when students do this problem, they will all of a sudden switch places and they'll do DG over CT. But hopefully you're realizing and seeing that now I'm taking the small and putting it over the big. I don't want to do that. I want to be consistent with my choice. Since I did big over little, I'm going to continue that with this fact here. So I'm going to take side CT, I'm going to put it over side DG. Well, CT has a side length of 20, DG has a side length of 5. 20 divided by 5 simplifies to a 4, and we are in good shape. Right now, we have proven that two sides of this triangle share the zoom factor of 4. Our final fact that we have to find out is whether or not side AT and side OG, whether or not they also have that same zoom factor. So let's go ahead and end this flow chart by taking side AT, putting it over side OG, realizing that AT is 24, over OG, which is 6. 24 over 6 reduces to 4. And we now know that every side on these two triangles share a zoom factor of 4. Because of the fact that these two triangles share the same zoom factor, that is enough for us to say that those two triangles are similar. So I'm going to go ahead and write out that triangle CAT is similar to triangle DOG. Why are they similar? Well, we proved that with side-side-side similarity. Each side shared that same zoom factor of 4. That is enough for us to know that those two triangles are similar. We know that this smaller triangle here, DOG, was just given a zoom factor of 4. It was dilated to create this larger triangle CAT. Alright guys, it's that Math Magician, and I'll see you next time.